Find the volume of the solid formed by revolving the region bounded by the curves y equals x squared and y equals x cubed around the x-axis. Leave your answer in terms of pi. Let's get a visual. All right, let's get a visual. Y equals x squared is going to look like u. Perfect. Y equals x to the third is going to look like u. So we have this tiny, 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 tiny little sliver right here. A tiny little sliver right there. And what we're doing is we're rotating it around the x-axis. And by rotating it around the x-axis, we don't get what we normally think we get. We don't get a solid like we did in the last couple sections. We kind of get this cup, this actual empty looking like a wine glass type thing is what we end up with. So we're not going to use the regular disk method that we're used to. We're going to use the washers method. Now this is called washers, just like the tool where you have the hole in between. That's kind of what we're dealing with here. We are dealing with a shape that, is like a cup. It is solid, but the inside is hollow. So this is the washers method. The washers method is found by doing pi times the integral from a to b, and we'll figure out what a to b is in a minute. We're going to take your original equation, so labeling you f of x, right? Or whatever one is f of x. One of them is going to be f of x, one of them is going to be g of x. So let me not label things yet. Okay, we're going to take one equation, f of x, we're going to square it, and then we're going to subtract g of x, which is going to square that too, and then dx. So this is different from the disks method around a different axis because we're taking into account that hollowness right there. Okay, now according to the picture that I drew out, my top equation appears to be x to the third, and my bottom equation appears to be, or do I have it backwards? No, my top equation is actually x squared. So that's my top equation is going to be x squared. So you are going to be f of x, and you are going to be g of x. Now, does it matter? No, because what I get is like the same exact answer, but negative, and I'll just make sure it's positive because I'm not stupid. I need my limits of integration, though. And my limits of integration are going to be found by me taking these two equations and setting them equal to each other. So x cubed equals x squared. Subtract x squared from both sides. Factor out an x squared, giving you x minus 1. And you get 0 and you get 1. Those are my limits. So the equation that I set up for this problem is going to be pi times, or the integral from 0 to 1 of x. So I'm doing x squared minus x cubed squared dx. That's going to equal pi times the integral from 0 to 1 of x to the fourth minus x to the sixth dx. Now let's integrate that. Okay, 1/5 x to the fifth minus 1/7 x to the seventh, limits at 0 and 1. No big deal. Let's plug in 1. Pi times 1/5 times 1 to the fifth, easy peasy, minus 1/7 times 1 to the seventh, easy peasy, minus, let's use common sense, if I were to plug in 0, I get 0 minus 0, which is 0 times pi minus 0, so you get that. Pi is still living on the outside. 1/5 times 1 to the fifth is 1/5 times 1, which is 1/5. Minus 1/7 times 1 to the seventh is 1/7 times 1, which is 1/7. Did you catch all that? Now we have 1/5 minus 1/7, so let's multiply the top and the bottom by 7 and 5 respectively. 7/5, 35ths minus 5/35ths is going to be 2/35ths. And 2/35ths times pi is 2 pi over 35. Dog. Find the volume of the solid formed by revolving the region bounded by the curves y equals x squared and y equals x cubed around the y-axis. No, leave your answer in terms of x or pi or whatever that is. All right. We did a very similar problem in the last problem. Those of you who watch all my videos in order religiously know what's going to happen. Okay, you graph y equals x squared. I'm still graphing it like that. You graph y equals x to the third, and that happens. You have this neat little sliver that's going to take place in between. Now we're spinning it around the y-axis. So by spinning it around the y-axis, you basically get a hollow bowl. So this is going to require the washer method. Okay, the washer method, and by the way, this is, around the y-axis, if we're dealing with y's, the washer method is going to be pi times your integral from limits of a to b, we'll figure that out when we have to, f of y minus g of y, square both of those, dy. All right, so what I need to do is I need to solve both of these for x before I do anything. Solve both of these for x. So I'm going to I'll do that over here where I have a little bit of space. Y equals x cubed and y equals x squared, square root, cube root, right? This becomes x to the, I'll write it out as y to the 1/3 because I'm going to need to write it out that way anyway. And this will be positive or negative, so I'll write this out as x equals positive or negative y to the 1/2. Now the positive or negative part's just going to go away. You'll see why in a little bit. Although, it doesn't really matter because I'm spinning it around. So these are my two equations. All right, these are my two equations. Let's set this puppy up. Do I have my limits yet? No, I don't even have my limits yet. Ugh. All right, so my limits are found by setting these guys equal to each other. So y to the 1/3 equals positive or negative y to the 1/2. Why don't I do this to make my life easier? And to the 6th power both sides. So you become multiply the exponents, y squared. You become multiply the exponents. Anything to the 6th power is going to become positive, so y to the 3rd. Subtract y squared from both sides, so I get that. Factor out y squared, so y squared equals y minus 1. And my limits are going to be 0 and 1. So now I can finally set this thing up. So pi times 0 to 1's integral of 5y squared. So I think I'm going to use let me see, the outer one would be the cube. So I'm going to do y to the 1/3 squared minus positive or negative y squared, or to the 1/2 squared dy. You become pi integral from 0 to 1 of y to the 2/3 minus, you essentially cancel out, and so do you, just y dy. That becomes pi times 3/5 y to the 5/2, just reciprocal stuff, minus 1/2 y squared with limits existing at 1 and 0. Okay, pi still lives there. Plug in 1, 3/5 times 1 to the 5/3, which is going to be 1, minus 1/2 times 1 squared, which is also going to be 1, minus, if I plug in 0, you become 0. If I plug in 0, you become 0. 0 minus 0 times pi is 0, so that makes life easy. You become pi times 1 times 3/5 is 3/5. 1 times 1/2 is 1/2. Okay, multiply u by 2 over 2, so pi times 6 over 10 minus multiply u by 5 over 5, 5 over 10, and you're going to end up with pi times 1/10, which is pi over 10. Breathe in, breathe out. Washers. Find the volume of the solid formed by revolving the region bounded by the curves y equals x, x equals 0, and y equals 0 around the x-axis. Leave your answer in terms of pi. I intend to. Let's draw this out. Let's draw this out. Y equals x, easy. Y equals 0, that. Or x equals 0 is the y-axis, that. Y equals 3 is that. So we have 3, we have x, and we're spinning it around the x-axis. So by spinning this around the x-axis, what we're doing is we're creating this weird circular shape that I will absolutely do a terrible job drawing out. But that's what we're going to get. I'll give myself some credit. That's not that bad. But what this is going to require, since there's space in between, is the Washer's method. Now, the Washer's method is found by doing pi times your integral from a to b of your upper radius f of x squared minus your lower radius g of x squared dx. What I don't have right now are my limits, except for the fact that I kind of do. You're 0, and if x is 3, then x is 3. So I have my limits already. So I can pretty much say, all right, well, the 3 is going to be my top part, so you're going to be my f of x. You're going to be my lower part, so you're g of x. And this problem is not going to be super bad. So pi, I mean super bad compared to some other problems that could erupt. 0 to 3. I called f of x 3, so 3 squared. I called g of x x, so x squared dx. So you become pi 0 to 3 of 9 minus x squared dx. Now we can integrate. Leave that pi out there. Pi times the integral of 9x minus 1/3 x to the third. Limits are 0 and 3. Plug in 3. Pi times 9 times 3 minus 1/3 of 3 to the third power minus, common sense says if I plug in 0, I get 0 minus 0, which is 0 times pi, which is 0, and 0 is what I get, 0, 0, 0. So pi times 27 minus 3 squared is 9 times negative 1/3 is 3. No, 3, that should be 3 cubed. Ah, that was a close one. Oh boy. Oh, so 3 cubed, oh boy, is 27. 27 times a third is 9, so 27 minus 9. Oh boy. Oh, pi times 18. 18 pi. Phew.